All right, so we're going to look at some, I call them special limits, but they're really not special. These are just trig limits. So trig and limits mixed together. A majority of your trig limits are going to be just like plug and chug. So like if I want the limit as x approaches pi of the cosine of x, I can just plug pi in. So the cosine of pi is -1. Now this might be one where you want your unit circle out. You can also use your calculator, but make sure you're in radians if you're going to use your calculator, unless they're not going to come out right. So another example might be the limit as x approaches pi over 4 of the tangent of x. So that means I just need the tangent of pi over 4. Well, I know that tangent is sine over cosine, so it's the sine over the cosine. And I know that the sine at pi over 4 is the square root of 2 over 2. And I know that the cosine is the same, square root of 2 over 2. So therefore my tangent is 1. Now I could have got that with my calculator as well, but I like to keep using the unit circle values just to make you guys think a little bit about unit circle values. So some of them are very, very easy. The ones that are harder are the ones where they don't work out, or you think their answer would be does not exist, but it really does exist. So for example, the limit as x approaches 0 of the sine of x over x. Well, the reason when I try this one, if I put 0 in, the sine of 0 is 0 over 0. That's what I called indeterminate form. So I know that it's probably does not exist. And I could look at the graph, and if you wanted to go to Desmos, you really could look at the graph. I'll show you really quick, and it'll give us our answer right away. So the sine of x over x, it looks like at 0, it looks like my answer should be 1. Does not exist. So how did they get that algebraically? Well, this one is actually kind of a special just rule one. The limit as x approaches 0 of the sine of x over x actually equals 1. That's your answer. And it's kind of almost one that I just memorize. It comes from a theorem. In this class, we don't get into the theories as much as just doing the actual algebra. But the theory that this comes from is actually called the squeeze theorem. Some people call it the sandwich theorem. You can call it either one. What it means is maybe I have a function up here. We'll call that like g of x. And then I have another function over here. Maybe goes like this. And we call that one h of x. And we know that at this point right here, they're equal. So if I have a third function that I want to just throw in there, I'll make it green. If I want to just throw my third function in there, if my third function looks like this, I know at this point that this one has an answer, my h, and my g has an answer, so therefore my f has to have an answer. And we can prove that the limit as x approaches 0 of sine of x over x equals 1 with a proof, which I'm not going to do in a video for you, but we can prove it. But we do need to know it because it's something that we use. So for example, you might have a problem that's like the limit as theta approaches 0 of the sine of theta over 5 theta. And I use theta because sometimes the book doesn't use x, sometimes it uses theta, and I just want you to get used to that. They're the same thing. Theta and x are the same. So if I look at this, I know that the sine of x over x equals 1, but that's not. So like I was saying, I know that the sine of x over x is 1, but that's not what this says here. But what I can do is I can just factor out this 5. So if I factor out that 5, and I don't have anything in the numerator, so that's actually saying 1/5 to keep the 5 in the denominator, times the sine of theta over theta. And I know from my rule up here that the sine of x over x is 1, so the sine of theta over theta would also equal 1. So I would have 1/5 times 1. So my limit equals 1/5. So that's an an example of how we would use that. So let me show you another one that would use that just to kind of get us in the practice of that. So what if I had the limit as theta approached 0 of the sine of 4x all over x. So once again, we got to do a little bit of manipulating to this because it doesn't quite match our one that we know. So this one says the sine of x over x. So if it was a 4 here, I would need there to be a 4 there, which I can do, but there's this little rule in algebra is if I multiply this bottom by 4, I have to multiply the top by 4. So really, I'm going to multiply by 4 over 4. So that means I can get my 4x in the bottom, but I have to multiply the numerator by 4, basically so that they would cancel. So then I have 4 times, so I'm going to leave that 4 in the numerator, the sine of 4x over, I'm going to bring this 4 and multiply it here, 4x. And then I know that since now these are the same, I can cancel this and I get a 1. 4 times 1 is 4. Okay, so let's try one more. This time I'm going to have the limit as I'll use x again. X approaches 0 of the tangent of x, that's a t, the tangent of x over x. Now when I try this, I know that the tangent at 0 is 0 over 0, so I'm going to have to do something. So I got to think back to pre-calc. The tangent is the sine of x over the cosine of x. And then we still have x in the denominator. So now I'm going to combine these. This is a complex fraction, so I'm basically going to multiply by the reciprocal of this. So I'm going to multiply by 1 over x, because that's the same as what I had there. So I get the sine of x over x times the cosine of x. Now, I still don't match that little rule that I had up here, sine of x over x, because that's what I'm trying to get to. But what I can do now is I can break this up. I can say this is the sine of x over x times, I still have cosine, so I'm going to have 1 over cosine of x. And that's a legal move in algebra because you're multiplying, so you can do that. I know that this one, the sine of x over x equals 1 times. Now the cosine evaluated at 0. So if I put 0 in here, the cosine at 0 equals 1. So it'd be multiplied by 1 divided by 1, or 1, which is 1. So there's not tons of algebra in this. It's just understanding what they want. So what we learned is that the limit as x or theta or whatever variable you're using approaches 0 of the sine of x over x is equal to 1, and I can move things and manipulate things until I can get that and use it. Now there is one other one that I want to show you, and it doesn't show up as much as this one. This one's pretty popular. The limit as x approaches 0 of 1 minus cosine of x over x. This actually equals 0. It's not undefined. It exists. Its answer is 0. If you graph it, you could see that. Let me show you an example of that one. So let me find one to show you. Okay, so we'll just try a basic one here. The limit as x approaches 0 of 3 times 1 minus cosine of x all over x. So what they're trying to show you here is I can break this up into 3 over 1 times 1 minus the cosine of x all over x. Well, and I know that this equals 0. So 3 times 0 is 0. All right, that's it. If you would go back into Canvas and try the problems with limits and trig functions.